Use compile time style selection. When using Qt quick styles rather than importing Qt quick controls and relying on runtime style selection, specify the style directly within the QML file. Explicitly import the style you plan to use, such as Qt quick controls basic, fusion, or material. Doing this allows the QML compiler to determine the style library in advance, optimizing code generation and improving efficiency. At the top of the main.qml file, you may already see a specific style import, such as basic. This ensures that the application window control follows a defined style, providing a consistent appearance like a white-filled background. Avoid shadowing properties. Property shadowing occurs when you redefine a property that already exists in a component. For example, adding a rectangle and declaring a property string radius results in shadowing. The rectangle already has a radius property of type QReal, and by adding a string property with the same name, you override the existing one. To demonstrate why this is problematic, add an item with a property string r that binds to parent.radius. Neither you nor the compiler knows what type parent is, whether it's the QReal or the string property making this a guess. If the item is moved or its parent changes at runtime, there is no guarantee that the new parent will even have a radius property, leading to potential errors. If you really need to use a different type for a property like radius, the best practice is to be explicit in the binding. Assign an ID to the rectangle, such as myrect, and change the binding from parent to myrect. This way, the compiler knows exactly which object to reference, ensuring that it's using the string property. It also makes the item safe to move without breaking the binding. In C++, you can prevent shadowing by using final in your QProperty definitions. This will raise a compiler error if a property is overridden, ensuring clarity. Using final also optimizes code, as it allows the compiler to call the accessor directly without traversing the class hierarchy. In this section, we explored several QML-specific constructs and identified potential deficiencies in code that may still work but have underlying issues. We examined how to leverage QML's strengths and tooling to maximize the development experience in the IDE, ensuring code quality and efficiency. By demonstrating examples of common mistakes and improvements, we provided you with practices that you can integrate into your own projects. While the QML language continues to evolve and become more rigorous, certain areas require special attention to align with best practices, even if they are not yet strictly enforced. Remember these key principles. Be explicit when writing QML. This is the most critical aspect of good QML code. Do not ignore warnings or errors from QML lint or the QML compiler. They are there to guide you in fixing issues. Make sure the QML compiler, QML lint, Qt creator, and the code models understand your intentions clearly, ensuring a smooth development process.